So I'd like to introduce the next session. The main speaker, I think he's going to show some slides and possibly a video. I'm not 100% sure. The speaker is Dr. Rubik Biswas. I just met him, so I can't tell you extempore too many things about him like I used to do before. He has been at NASA Ames Research as the Director of Exploration Technology for a while now. He joined them in 1991 after his PhD from RPI, Rensselaer Polytechnic. He is considered an expert in high-performance computing. He has won many awards. I suggest you take a look at his biodata to find out more. I'm not sure if Piyush is going to interact with him or what, but Dr. Biswas.
Thanks for being here, sticking out. It's late in the day. I know it's been going on for a while. I'm glad to be here. I'm going to use these slides more as a prop. I'm not going to spend too much time on each of these slides, but again, this is a very different talk from what you've been hearing all morning. First of all, I'm from NASA, so this is US federal government, and very different from everything that you have heard this morning. But also, you know, NASA has been at the forefront of innovation for decades. And NASA is probably also one of the most diversified federal organizations or government organizations in the world. We do everything that you can think about is done at NASA. So, but again, all of that is data-driven, and what NASA does is out of the ordinary. It's not, we do things that are hard. So even though there's a lot of data, you don't know what to do with that data. So let me just quickly show you what the basic driving things within NASA are. So at this time, NASA is basically focused on 6 things. And you know, sometimes we forget, okay, the shuttle retired, so NASA is out of business. That's not how it is. And so here are very quickly what the 6 major things that NASA does. One, of course, is Earth. People forget that, but NASA has a unique perspective of Earth that no one else has, because we are looking at Earth from space. Every other organization in the world is ground-based. So they can do a lot of stuff on Earth, but no one can do what NASA can do. So that gives us a huge advantage or a hugely different perspective of Earth. Second, of course, is the International Space Station. That's a big partnership. And I know that the theme of this conference is about partnerships and how we can work together. And the International Space Station, you know, it's international. It's a space station. It's a lab that almost anyone can use to do any sort of experiments that they want to do. And a whole spectrum of experiments are done on the station that involves multiple countries and companies. Of course, Journey to Mars. Most of you have probably seen The Martian. Most of the movie is accurate. We are not quite there yet. I think the technology is there to get to Mars and come back. The problem is that the round trip is about 3 years. So that's too much. So that's what we're trying to get out of or solve. But ultimately, at the end of the day, NASA's goal, you know, of course, with the new administration and everything, other things could change. But NASA's goal is to have a human on Mars in the mid-2030s. Finally, on the bottom, you know, technology drives everything. And of course, NASA does technology that is not available. So everything that NASA has to do has to be basically conjured up. You have to think about it from the ground up. Aeronautics, remember, many people forget aeronautics. But if you look at NASA, the first A in NASA is aeronautics. It's National Aeronautics and Space Administration. So almost every time you fly, everything that you always use came out of NASA technology. There's nothing in aeronautics that NASA has never done. In fact, before NASA was formed, NASA was known as NACA, and that was solely based on aeronautics. It was not about space at all. And then finally, which is probably the most difficult question, is are we alone? Is anyone out there? Is there life somewhere else? Where is the rest of the, what is the rest of the universe doing? And so those, if you think about those, that's how, and again, this is just one quick chart just to show, just to put everything in perspective. NASA is a relatively large federal organization. We are, of course, here in Silicon Valley, and that gives us a unique perspective because it allows us to collaborate with the Bay Area, innovation, and everything else that goes on here. So now let's just focus on Ames itself, and these are the 8 main things that we do at NASA Ames Research Center, which is down the hall right here, basically, down 101 or 237. So air traffic management, I'll talk a little, and I'll speak on a little bit about each of these just to show where the data aspects come in. Air traffic management, and you know, you can see that how that gets more complicated as you get into drones and everything else. Entry systems, if you're going to land on other planets and other solar bodies, or planetary bodies, entry systems is going to be the key because you're going to burn out. Computing and IT systems, of course, is key, and many of you are experts on that already. Intelligent adaptive systems is another key part. we are not going to be able to do everything ourselves. And especially when you're at Mars and at very far-flung destinations, everything has to be done right there. The round trip times are too long to make decisions on Earth and make decisions based on that. And then, of course, the low-cost space missions. You may have heard about small sats, nanosats. Almost everyone is doing that because the question is, can you get 80% of the science done for 5% of the cost? Many of NASA's missions are billions of dollars. But can you do 80% of that for a few hundred million? Hundreds of millions is still a large number, but it's still cheaper than $1 billion. Aerosciences, of course, all of that, like I said, is tied to aeronautics. And then the final two things is about life out there. So let me just quickly talk about some of the things where data is important. And I'm not going to talk about everything on the slide. These are more, like I said, props. But if you're talking about air traffic management, as you throw in drones, and as you throw in all these other things that are going to happen, how are you going to do all of that? And if you look at I don't know if the image over there at the bottom right is working, that's all the airplanes in the US airspace. And if you look at it through the whole thing, you will see that as the day begins, it's a 24-hour thing, as the day begins, there's a lot of traffic on the East Coast, but then as the day progresses, that traffic slowly migrates west. And you can see all these flights that are going on into Asia-Pacific region. And so if you now throw in all the other drones and everything else that Amazon is going to deliver services, and so is FedEx and UPS, and then all the other people, how are you going to deal with all of that? Okay, so the next one. NASA has a lot of observational data sets, and a lot of that is available through what is known as a NASA data portal. Almost anyone, anywhere in the world, can go and download that data. And it has lots of Earth sciences data. There's data about the Apollo missions. There's data about Jupiter and Mars and the moons of Saturn. You can download all of that, and you can do whatever you want with it. But NASA also generates a lot of computational data. And NASA has some of the biggest computers on the planet that does a lot of analysis and simulation to generate data in order to understand things from both science, aeronautics, as well as engineering. Here are some examples. For instance, if you look at simulations, I hope this comes up. Yeah. So there's a lot of simulations going on. For example, if you're trying to understand the wake of a helicopter rotor wakes are significantly more different from airplanes. If you're trying to understand how rockets take off and what happens in the first 2 seconds before the rocket actually clears the launch pad, and trying to understand global climate and how weather patterns actually affect everything from your wine in Napa to some monsoon in India, all of that is determined by a lot of stuff that NASA gathers and is publicly available. One quick thing on intelligent adaptive systems. One of the things that we have been talking about here today is about data and machine learning and artificial intelligence. And what does that mean, though? It's not just the data. We are all completely drowning in data. What do you do with that data, and how do you actually use that data to make autonomous decisions? So we have huge collaborations with Nissan, for example, but also with other auto companies, not because NASA is interested in self-driving cars, but we are interested in self-driving rovers on Mars. And those are purely autonomous. Now, obviously, the challenges are different. The rover is not going to run into a Martian somewhere and kill it, and even if it does, we are probably not that worried about. But there are constraints about weights and other things. So there is a lot of things that are very similar between autonomous stuff on Earth and doing autonomy at a planet that is millions of miles away. The other thing is astrobiology and life sciences. This is probably the most difficult thing. The question is, if NASA has a mission called Kepler, where we are actually looking like Earth-like planets. So given that the number of stars there are in the universe, there's got to be planets that are rotating or revolving around other stars that are what are known as in the Goldilocks zone, that they are just the right distance away from that sun to be able to sustain life. And given the number of these stars that are in the universe, we believe that there is life out there somewhere. And so how do we get that? So one of the biggest projects in there is what is known as GeneLab. And GeneLab is basically a huge database of all kinds of omics data, from proteomics and genomics that is available freely to anyone who wants to use that information to decide how you're going to sustain life or find life in distant planets. And then finally, Earth and space sciences. I talked about it briefly, but again, if you think about the information that NASA collects in Earth sciences, again, if you look just at the middle column, there are thousands of papers that are written by Earth scientists around the world. And the problem is many of those are not reproducible. Someone downloads some data sets, writes an algorithm, produces a paper, gets it published in a journal, gets tenure at a university, and then there is no way another person can reproduce that. So NASA has this whole project called the NASA Earth Exchange, which basically captures that entire workflow from the data to the code to the results, so that the next scientist can come and either augment that, refute that, and whatever it is to advance the state. And so I'll end there with this very nice picture. In fact, I had a nice picture of the Martian at the bottom. But this is the big question that obviously everybody is interested in Mars. That's the big question, but how do we get there? There is the Earth-reliant part of it. This is low Earth orbit, and many of these things now we have transferred to SpaceX and Boeing, because NASA has decided that going to low Earth orbit, going to station, we have been there, we have done that. We know how to do it. And there is no way the government can do it better than industry. So we give it to SpaceX and let them do it. What we are interested in is the next step, which is the proving ground, maybe to some asteroid, and some other things, maybe in the lunar orbit or cislunar, or maybe at some Lagrange points. And then beyond that, how do we get to Mars? So anyway, I'll stop there, and if there are some questions, I'll take.
My friend, colleague, and co-conspirator Piyush Malik, who I introduced a short while ago, will join Dr. Biswas, and they'll have a chit-chat.
What do you think of the presentation here? Give it up. Thank you. Thank you. It's so heartwarming to see the kind of great scientific work happening at NASA Ames, and the way you presented. I think we are all salivating to see what's there that we can do as entrepreneurs, and how can we get engaged with NASA.
Right. Go to the NASA website and go look it up. NASA is a civilian organization. NASA's main goal is for the benefit of humankind. And so everything that NASA does is basically to gather knowledge and gather information so that life for all of us is better. And so we are always looking for partnerships. And on top of that, the only thing I'll add, NASA, as you saw in that map of the United States, NASA is in many places around the country. But because we are in Silicon Valley, and this is the hotbed of innovation, we are looking for partnerships all the time. In fact, NASA Ames has a section called the NASA Research Park, where there are 70 companies currently located. We allowed them to come on base so that they are in close proximity to us. They're outside of the fenced area, but they're still on federal property. We have 1,800 acres of prime real estate here, by the way. And so we are always welcoming people to come work with us so that they can be close to us and they can work on a variety. There is nothing, like I said, there is nothing that NASA does not do. Whether it be chemical engineering or biology, anything you talk about, we are interested.
Now I really need a field trip to NASA. All right, before we go there, let's see. You talked about open data science.
Correct.
And the data sets that are being collected by astronomers and private folks. How are you engaging with the open data movement?
Yeah. Well, one of the things, this is a federal government mandate. Because, like I said also, my salary, including everyone else's at NASA, is actually paid by all of you. So this is taxpayer money. So basically, you own the data. It's not my data. I'm not SAP or Oracle or IBM or Intel. Everything I do is paid for you. So technically, therefore, everything that I have is yours. So in fact, the data portal, if you go there, the NASA data portal, you can go in there. You can get any data that you want. And so therefore, there is always that opening. The whole point, that's called the data portal. You can download any data, you can request data. Of course, you'll have to have your own storage. You can ask for data, I'll send you the data. You'll have to deal with it, and you have to pay for the network costs. But you can have the data.
Well, there's cloud to store data
That's
in, right? And
right.
We have software there.
Yeah, we
can do that.
We buy your credit card, pay Amazon, and take my data and put it there. That's fine.
Well, IBM does do that too. So anyways, coming back on track here. So you talked about open data, and essentially, people actually who used to wonder, ever since it was announced that NASA will stop taking the space missions, refueling of the space station, basically given to
the Russians.
Not the Russians, but privatization.
Private company.
Private company.
Yeah,
So SpaceX. Talk about that.
Well, right now the Russians are important because the Russians are the only people, the only country in the world that can take people to the station. SpaceX has not delivered a person yet to station.
Do you think, are they on track?
Well, they have a contract with us.
Oh, okay.
Yes, so SpaceX will have to ultimately deliver people to the station.
Okay.
Yeah.
By when?
Over the next, I think over the next 3 or 4 years, something like that.
Oh, wow.
Yeah.
That's something new I learned here. So
Because like I said earlier, NASA is not going to be in the International Space Station business. We are focused on places beyond station. So we are looking at, like I said, asteroids. We are looking at, moons of Jupiter and Saturn. We are looking at Mars. We are not going to be servicing station anymore.
Guys, think about places beyond space stations.
Yeah, maybe come up with a startup company, talk to the VCs that were just here, say that you have a company that is now going to deliver people to station.
And I'm thinking of colonization of Mars. What do you think of Elon Musk's plan to do that?
Yeah, well, NASA's goal has always been that for the survivability of us, we have to be a two-planet species. We cannot just live off the Earth. So there's got to be another place where we should be able to live. But we have to live off the ground there. We cannot transfer stuff from Earth to another place and then live there. We have to be able to live off there. So things like 3D printing is extremely important. Things like synthetic biology, that is important. Things like autonomy, this is important. All of these little things are important. It's like, like the first people who came to the US. You leave, you're not going to go back. You have to live here somehow off the ground. So that's what you have to do if you're going to go to another planet.
Wonderful. On that note, thank you very much. Give it up for him.
Thank you.